recording our session now, and we can get started. So present here. Let's see you guys. Let's fix that. All right, so I think as I mentioned, this class is sort of the first time we're doing StyleGAN as a full class. So there might be some rough edges, or basically this is an opportunity for you guys to provide feedback. So if you're looking for something in this class and you're not getting it, and say week 2 or 3, you're like, are we gonna learn this thing? Let me know. And we can definitely make sure that that gets covered in class. So I know everyone answered, or most people answered the survey questions that we sent out. So that's helped a little bit. That might actually change some of our schedule, but it's really helpful to hear from everybody. So again, this is a class for you, and you should feel free to like ask whatever you want, and we can work through trying to add that material in. Okay, so the objectives for this class. The #1 thing for me is I want you to make stuff. It's very easy to just sit here in my lectures and like soak the information in and feel like you know what you're doing, but I promise you until you start making stuff, you won't actually really understand it. So make sure that you are trying when you can. I know everyone's schedules are a little bit crazy, and obviously in the current moment we're in, things are a little bit weird. Try to make as much as you can. So I have homework assignments for every week. The hope is that you do those homework assignments at least in some point, because it'll help you understand the materials better. So we're going to talk a lot about GANs, especially today. And one of the things I think is really important about StyleGAN in particular is that there's a whole community of people who are actually working in it, which I would say is actually very different than a lot of other machine learning materials where there's maybe a handful of people working on stuff. I would say with StyleGAN in particular, there are a lot of people making things, a lot of people adding to sort of the knowledge around it. And that's really great, but it also means things move fast. So even this week, someone released some stuff I'm gonna try to teach in this class. So it's pretty exciting how fast it moves, but there's a lot to keep up with. And then we're gonna talk about how to stay up to date. So I'll give you some names of some folks to follow, some resources to keep in touch with, so even after this class, you can keep learning. So the schedule for this week, for this class is today we're gonna do some setup, we're gonna look at some history of GANs, and we're gonna look at some inspiration materials. I think this class might run a little bit long. I hope that's okay. We might run like 15, 20 minutes longer than expected, just because it's a bigger class, so intros took a little bit longer than we were initially planning. So just FYI, most class will be an hour and a half long. You're also welcome to stick around after class. I can answer questions for like 30 minutes or an hour if people have questions as we go through things. The rest of the schedule is maybe TBD, but this is sort of what I'm thinking we're gonna do. So next week we'll work fully in training. We'll look at parameters for training. We'll look at metrics. We'll look at anything related to training. Week 3, we'll look at how to actually, once you've trained a model, how to manipulate it using interpolation, using any number of other sort of techniques. Week 4, we will be looking at what I'm calling advanced techniques. That will be anything from looking at adding class labels to your data, or things like using audio to manipulate your visuals, like those sort of things. And then week 5, I usually find that the last week is good as just sort of an overflow week, and or people to show off what they're working on, or to have some like question and answer with me. It's just a good moment for like, as we wrap up class, people ask questions, that sort of thing. As a part of your class, you also have one-on-ones you can schedule with me. It'll basically just be like a Calendly invite where people can schedule a time to talk with me about 20, 30 minutes, either on a project they're working on additional questions they have, that sort of thing. That invite to sign up for those will go out sort of the end around week 3. And I recommend that you probably have a project in mind so that we can sort of like go through stuff together. And you're welcome to schedule those at any point. You can schedule it immediately in week 3, you can schedule it after class is over, those sort of things. So it's pretty flexible, but it's a good opportunity to sort of like have one-on-one time with me and Leah. So this class is sort of the advanced class. I would say this is like, there's a much longer expectation for homework in this class. So Moises and Fabiola are taking my runway class. Those classes are pretty short in terms of expectations. This is much more. So this will be 6 to 10 hours of homework every week, assuming you do everything that we assign. And that is just because it really, there's a lot of technical materials with this class and making data sets and that sort of thing. So it does take some time. And I would say like the more you invest in your homework, the more questions you're gonna have. And the more likely you are to use this opportunity with me and Leah to ask those questions and get answers. Obviously, the Slack is still around and you're always welcome to use the Slack whenever you want. But I just personally find that it's a little bit easier if you ask in class. You'll get a much better response from me, most likely. And I should also mention, so we have an hour-and-a-half per week of class lectures, but there's a ton of other content available on my YouTube site, as well as a ton of resources that I have that links to or whatever. So, you know, this class for some of you might actually be more than an hour-and-a-half of videos. Like if you really want to learn more about data sets, I have a whole collection of data set videos, like that sort of thing. My general thing is like ask questions, like this is your opportunity to use me and my brain and to ask Leah and I questions, and please ask. So we can always provide you more materials if you're interested, and there is a lot of material available. So just go ahead and ask at any point or at any time. So I do want to talk really quickly just about approaches to this class. So I mentioned I would love to have everyone do the homework assignments every week. I recognize that for many of us in our schedules, that's not possible. But I think the best approach would be to do that, to do your homework every week. The second approach I think you could follow is just think of one big project. So this class, you've got the opportunity to do multiple training sessions if you want to, but maybe you just you have one idea for a project you want to do and you just want to work off that. I think that's pretty reasonable. I think most of the homework assignments will like basically lead to that, but it just depends on sort of your schedule. If you want to sort of watch some videos and then wait for the end of class to actually work on things, that sort of thing. And then obviously the approach I don't really recommend, but it is a thing you could do if you want to, is just show up to these sessions, watch the videos, get the recordings, and then whenever you want to do your thing. Really quickly, I want to talk about who I am and just my work. I hope you've seen some of my work on the internet, or you just signed up for this class fully confident in me, which I appreciate. So I am a product designer by day. I actually work at MailChimp, which is probably why you saw there was a MailChimp Zoom link. I've been a product designer for at least a decade now. I've been a graphic designer for 15 years. Most of my work is involving technology of some kind, even if I'm not the one writing the code for it. And about 2 years ago, a little bit longer than 2 years ago now, I took a class at SFPC, which is the School for Product Computation on machine learning. It was a similarly intense class to this, where it was actually just 1 week, and every night for about 3 hours, I would learn from these great folks. If you're not familiar with any of these people's names, I definitely recommend looking them up. A lot of machine learning smarts within all these people, as well as some additional design or like technical art theory and that sort of stuff. These were actually my first experiments in GANs. On the left here is a DC GAN, which we'll talk about. And actually on the right is also a DC GAN, but they're just trained a little bit differently and using different techniques to generate sort of this like crazy chaotic collage versus a more singular image that I then ran through a super resolution network to get a high res print out of. And here's sort of my current work. This is some StyleGAN2 work. I mostly work with like floral data sets. I'm really interested in sort of technology and nature. So this is some of the work that we'll be looking at later this week. Today, let's say today. So we're gonna go full in on StyleGAN, and I've been working with StyleGAN for about 1.5 years now. StyleGAN2 came out, I guess, the end of last year. So we'll be doing a lot of work in that. So it'll be great. Leah.
Next slide.
Oh wait, I skipped one. Wait, no, okay.
Oh no, I removed it.
Okay.
But yeah, so some intro. So I went to the School for Product Computation for their fall session. I think it was their last actual in-person session before COVID hit. And that was last fall. Before that, I worked at Facebook as a machine learning software engineer for about 1.5 years. I was training image and video classifiers to take down harmful content like terrorist propaganda. And so I was training classifiers on like bad content. But then I quit to focus on art and technology and the enmeshment of the two and attended School for Product Computation. After that, next slide. I started doing some remote research with a university in Saudi Arabia and presented at a workshop at NeurIPS. They have a cool workshop called the Workshop on Creativity, where they focus like pretty much entirely on like machine learning and artwork, and had a lot of cool speakers. These images are images that the network I trained produced. It was trained on a wiki art data set, and the idea was to try to make a GAN think like kind of produce creative outputs that did not look at all like the training data that it was trained on. And yeah, I TA'd for Derek for his last remote session, which was artificial images. And these are some things I made. The thing on the left was StyleGAN, trained on images of little planets scraped from Flickr. And then the thing on the right is a next frame prediction model on the beginning of an Adult Swim off the air episode. Yeah.
Cool. Yeah, I'm really excited to have Leah as a part of this class again. If you're not familiar with NeurIPS, that's probably one of the biggest conferences in the world around AI. So obviously, like, she has her bona fides. So I'm really glad that she's a part of this class. I saw Will joined. Will, do you want to give a quick intro? You haven't missed anything. Will is late because of me. I screwed up and like didn't send him all the info for class, so not Will's fault that he's late.
Hey. Great to meet everybody. My name is Will. My pronouns are they and them. I'm in Boston right now. I have a background in music composition, but I have a day job designing video games, and I'm hoping to get back to making more art and hoping that, yeah, I'm excited to be in this class. Great to meet everybody.
Thanks, Will. You didn't miss much. We just did intros, so we're just getting started with class, so cool. All right, so I want to talk a little bit about some of the requirements for this class. So we are going to run long, I can tell already. We'll also take a break after, like, I've got like 2 things I want to talk about. We'll take a 5-minute break and then we'll come back for class. If you do need to leave early, that's fine. Remember, we'll be recording the session, so you'll be able to get it afterward. Okay, so requirements for this class. I know that I think everyone has seen the email that we sent out about signing up for Google Cloud Platform. If you haven't yet, that's fine. It'll just be a part of your homework. It takes about 30 minutes to set up. The video I recorded should be pretty straightforward. Basically, we'll talk a little bit about using Google Cloud Platform. We'll use GitHub, and we'll be using Collab. So I also know that people are interested in potentially setting up their own machines. So for this class, I would prefer we all use Google Cloud Platform just because it reduces the annoyance of having to figure out CUDA for everybody and that sort of thing. If you are interested in setting up your own machine after class, like maybe the last week of class, I'll talk through like the types of things you need to do and all the things you need to be aware of. Really quickly though, I'm gonna say, so like technically you can use something smaller than 16 gigabytes as your GPU. You can use an 11 gigabyte, but you'll be a lot more limited into what you can do. So basically you'll have to train stuff smaller. You'll have to maybe even use StyleGAN2. There's a couple reasons for that, which we'll talk about throughout the class. But essentially if you have yet to do GCP, I would recommend their 11 gigabyte machines, which I believe are the P100 and the V100. And maybe is the K80 an 11 gig, 16? I think the K80 might be a 16 gigabyte. I would just do your homework and double check. I'm generally recommending the P100s or the V100s for class. The P100 will be like pretty good. That's what Collab runs on. It's fairly fast. The V100 is faster, but it's obviously more expensive as well. So I think the P100 was like $1.11 an hour. And I think the V100 is like $1.75 an hour. We'll talk a little bit about pricing and that sort of thing in a minute. The other things that you need to know for StyleGAN2 are that if you are going to run your own machine, you need to be using CUDA 10. I personally have found 10.0.130 to be the best. I do think 10.1 and 10.2 will work as well though, but you need minimum CUDA 10. And then CUDNN 7.6.2. You can use some higher versions as well, but this is generally what I recommend. This all comes pre-installed on GCP if you use the setup that I have outlined in that video. So take a look at that video. That's probably what I recommend for anyone looking to start. It's probably the easiest way to start. So why we're using GCP? So the reason we're going to use GCP is that Google, being Google, gives you $300 in free credits upfront when you sign up for the very first time. If you use the P100, which is like I think like $1.11 or $1.12, that equals about 250 hours, which is going to be pretty good for this class. That will definitely get you at least one model trained, if not more. So it's pretty, like, that's pretty good that that's essentially a free training for this class. It's sort of one-click install. You have to do a lot of pre-setup, which is what the video that I outlined, it makes available for you. And they have 16 gigabyte GPUs, which is really, really helpful. Almost a necessity for this class. If you are more advanced in setting up servers, especially GPU servers, they do have, you can set up like 1x, 2x, or 4x options. Obviously, the price will change a lot with those. But if you want to train stuff really fast, you are welcome to use those. I'm going to train, or I'm going to teach this class like everyone is using one GPU. If you are using multiple GPUs, just let me know and I can just tell you what you need to do. There's a couple settings you have to change. But for the most part, I would recommend 1x to start with. It means stuff will train a little bit slower, but knowing that we have a week between classes, it should actually be fine. It's not the end of the world if it takes 3 days to train a model. I do a video for the setup. I recommend checking that out when you're available if you haven't done it already. That will walk you through the setup on GCP. Once we're set up on GCP, you'll need to install a couple different StyleGAN2 models. So in this class, I'm actually going to try to teach a couple different models. These are all StyleGAN2 from like a basic architecture standpoint, but they all have slight differences in how they work or some modifications to them. As I mentioned, one of the great things about StyleGAN is that there's a big community and lots of people are doing new mods and modifications to things. So it's pretty cool to actually watch in real time how quickly this has grown. I think the StyleGAN2 model came out in December, and like by January, there was this non-square model. Peter Bailey's added his conditional labels in like, I think February. So there's lots of really cool stuff here. Really quickly, this first one is my fork. It's really basically the NVIDIA model, and it just adds a couple little things that make training a little bit easier. So that's, if you wanted to like do just basic StyleGAN stuff, you can use this fork. The Skyfly Nil fork is, I believe, someone from China who has built in how to do non-square training. So we'll talk about that a little bit more next week, but you can, so the basic NVIDIA model assumes that all of your image inputs are in your data set are gonna be square. This model allows you to alter that. So you can use rectangular models, which is really cool. The thing about the rectangular models is they have to fit into a very specific size format, which I'll talk about a little bit at the end of this class. And then Peter Bailey's model is, uses conditional labels. If you don't know what that means essentially you can have a data set of different artistic styles, and you could label all of your images with those different artistic styles, train the model on those artistic styles, and then it would, in the reverse, you could actually start to ask for different images in an artistic style. So in other StyleGAN2 models, when you throw all of your art at this model, it basically sort of merges them all together. So if you have very different types of images, it's actually going to almost like sort of collage them together, and it doesn't necessarily train as well. So Peter Bailey's conditional labels model is supposed to make that a little bit easier. It's a little hit or miss if it actually works as well as we would like it to. His wiki art model does work pretty well, but I've seen some other folks have issues. But either way, like, these are 3 good models. I would say I'm probably not going to teach the Peter Bailey's one until the end of class. So if you are really interested in conditional labels, maybe start with a data set that could work without conditional labels, and then we'll cover this sort of at the end of class. And I'll talk about what that means. I actually haven't done, I haven't set up my own data set with this, so I'll need to understand a little bit more about the type of data in order to parse this, but it's pretty straightforward. It's like a JSON tree of labels and image names, and then you combine them together when you're building your data set. So I'll have a video for that, as well as we'll talk about it sort of in later parts of the course. So I should note that this one requires some sort of special data set setup. The other 2 are going to be more straightforward, where you just need basically a folder of lots of images. And lastly, we're going to use Google Colab in some cases. You don't need to use Google Colab. Like, you can run all this stuff in GCP if you want to. I personally find Collab to be kind of a nice way to do inference and or interpolation. just because you can tweak settings a little bit more easily inside of Collab. Collab is a thing from Google. It's free, but they have a very limited time amount. You get it for about 12 hours at a time, which means it's really painful to train on. Training a StyleGAN model usually takes about 3 to 4 days. So if you were to try to do that in Collab, like every 12 hours, you have to restart your machine. And it is very annoying. I have a video on how to do it if you're really interested in like basic training for free forever that you can follow. But I definitely would say like really decide if it's worth your time and effort to constantly restart your server. So that's possible, but we won't really use it in this class to do any training. We'll mostly use it for inference and interpolation. So we're going to use GCP to train our model. We're going to bring our model down, download it, and then we'll upload it to Collab and be able to do some interpolation and other things with it. I do have a Collab tutorial playlist. If you've never used Collab before, it is like Jupyter Notebooks. If you've never used either of those before, I have some tutorials on how to like get started with that. It's pretty straightforward. The nice thing about Collab or like notebooks in general is that there's text and lines of code that can be run simultaneously. So it's kind of nice for tutorials to like read a little bit, run a line of code, read a little bit more, run a line of code. So it's pretty nice in that regard that you can sort of build a tutorial like that. Okay, so data set requirements. So I know that in the survey there were a lot of folks interested in making their own data sets, and that is definitely a part of this class. However, I will not be teaching a lot of materials on generating your own data set. But let's talk a little bit about StyleGAN needs for a data set. So it needs, realistically, it needs a minimum of 500 images, and I would say that's very, very low. If you use 500 images, you will likely run into some issues, which we'll talk about throughout the course. I would say it's much preferred to have about 1,000 images, and honestly, the more, the better. And what I mean by images is like an images of a similar like sort of data set, right? So we can think about all crop faces cropped the exact same way. We could think about flowers, you know, photos of similar items. So in the case of something like artworks, you might want it to be mostly like the same artist or the same type of artwork. So pointillism or pop or, you know, whatever it is, like try to keep things pretty narrow in terms of like how the types of images you're feeding it. Your data set does require the exact same crops. In the case of square crops, it can be 1024, 512, 256. In the case of the non-square crops, they need to be somehow multiples of 128s. So that could be 512 by 1024, that could be 256 by 512, but they need to be multiples of 128s. And I would not go above 1280 because you require, basically like that'll max out your GPU. So I would say at most you can do for squares 1024 by 1024. For non-squares, you're looking at like 1280 by 768. So that's just to be aware of like your size limitations. And there are, so the class labels I'll talk about more later, but you can use that, can use class labels. So if you have, if you're downloading from WikiArt, you can actually label stuff. I would recommend to start with, keep things in separate folders, then merge them all at once to train on one of the basic models, and then we can go from there for the Peter Bailey's work. Yep, Moses.
Yeah, I had a question about the similarity idea. Like,
yeah.
What is it like you kind of see like an overall shape or aesthetic, or like even the example with the artworks I find interesting because what you'll just won't see as much consistency in the output. It'll
like, and that's something to explore with, to be honest, because you know, depending on what you want to produce, if you want to produce like realistic, like fake looking images of a real data set, you want them to be really, really close to each other. If you want to produce something that's a little bit more creative, you might want to explore like how diverse that image set is. I have a couple of videos, so I'm gonna have a link to like my whole data sets playlist on YouTube, where I do talk a little bit about image diversity and what's right and what's wrong. I would generally say like for most folks, it's probably better to keep it similar to each other. But if you do want to explore, you can play with things and see what happens. What's nice in this class is like GCP probably is enough time to like build 2 models. So you might want to build might want to try one model that is like more diverse, and then try another model that's more closely related, and see what happens.
What I had one other question.
Yeah.
So is StyleGAN, the architecture for it, like much different than like a big GAN or DC GAN, like in terms of like the data set that you need to train it on?
The data set is the same. What is different is the architecture and how it actually is trained. And I'll actually talk about that today. I'm going to go through a quick history of different GANs and the different architectures that they use. I won't go too much into architecture because that's a little bit beyond the scope of this class. Like that would be like advanced. But I will just talk about like how they operate a little bit differently and why certain things, like, so for example, DC GAN can't really do much above 128 by 128 because of its architecture. It'll sort of collapse otherwise. Whereas StyleGAN is built to really be able to handle really large sizes, and that's sort of what makes it special. Also, you're hearing my cat Bug. She will talk constantly through these classes, so. Okay, so within data sets, so things I recommend trying to do if you've never scraped images before are, I have some videos on how to scrape Instagram, how to scrape Flickr, or how to scrape Google Images. I'm also probably going to do a video in the next week or two on scraping an individual website using a thing called Beautiful Soup. Basically, what I would recommend is if you've never done scraping before, talk to Leah or I, just to like tell us what your idea is, and we might be able to help you figure out exactly how to go about doing it. If you are used to scraping, then you're probably fine, and you just need to keep an eye on sort of the requirements for what we need. I have a playlist here that's linked to, and I'll link to it in our class notes as well, on how to build data sets, my recommendations, sort of demos of how to do it, how to install the software to do everything. I also have a repo called Datasets Tools that basically allows you to take thousands of images and crop them all the same size using various techniques. I recommend that because trying to crop everything to the exact same size in Photoshop or in some other tool is pretty annoying. It's basically a Python version of ImageMagick. So if you're more of an ImageMagick person and you want to use that, go for it. You're welcome to crop stuff however you want. I just find these tools that I built are pretty straightforward and easy. And since I teach them, there's lots of videos and tutorials about them. Okay, so I think that's actually, let's take a break unless people have questions. Let's take a quick 5-minute break and come back at 1:28. Does that sound good for everybody? Cool. All right, so I'll see everybody in 5 minutes. Yeah, and if you have questions, we can also take them after the break as well. So I'll see everyone at, let's do 1:29.